So, last week we looked at like terms, what that meant, and just really quickly, like terms are terms that have the same variables with the same exponent. So I might have xy squared and negative 2xy squared. Same variables, same exponents for those variables. All right. X plus 1 plus 2y. There are no like terms here. Different variables, and this can't be combined. Nothing here can be combined, so this can't be simplified. If I had another constant, I could combine those. Constants are like terms. Okay? So let's take a look. When we combine like terms, we're just adding the coefficients. So you look for like terms and then you add their coefficients. Okay. So these are like terms because they have the same variable, the same exponents. So we're going to add the coefficients. 3 plus negative 5 is negative 2, so this is just negative 2x. Okay, what are our like terms here? We have like terms, and then this can't be combined with these because it doesn't have a c. All right, so negative 8 plus negative 7 is negative 15c plus 2. Okay, so now you guys do the U-try. Okay, so what are our like terms? Anybody want to? Yeah.
4m and 12m.
And negative 12m. That negative is part of the 12. So then we have 4 plus negative 12 is negative 8m. And then you still have your negative 5. So it's negative 5 minus 8m. You could also put the variable term out front, negative 8m minus 5. All right, so evaluating expressions. And this is important to be able to do to check our work. So if we solve an equation and we get x equals something, we want to be able to plug that back in and check it and evaluate the expression and see if it's true for that value. So for these, we're going to evaluate these expressions with x equals 9 and y equals 3. Okay. So x equals 9, I'm going to substitute 9 where I see x. So 6 times 9 minus 10. So that's 54 minus 10. So that's 44. Let me just see if I have a better pen. I don't think I do. We'll try purple. Okay, now I have an x and a y. So I'm going to substitute 9 for my x and 3 for y. So 4 times 9 plus 7 times 3. So that equals 36 plus 21. So that's 57. What'd you get?
72.
That's what I got too. So I plugged in 9 for x and then 3 for y. So then this becomes 9 times 8, which is 72. Good. Well, we're going to start looking at equations. And an equation is just a mathematical sentence that sets two expressions equal to each other. An equation has an equal sign. And it can be true or false. An equation that's true sets two things that are equal, two expressions that are equal to one another. So it says 6 equals 6. It's a sentence. It says 7 equals 7. 5 plus 2 equals 3 plus 4. This is a true equation too because 6/12 is 1/2. These are false. 3 doesn't equal 2. So that's a false equation. 0 doesn't equal 1 plus 9, and 3 times 18 does not equal 40. So I can say it, but that doesn't make it true. Okay, so we're going to tell whether the two expressions form a true equation. All right. Okay, so 30 times 2 is 60, 7 times 9 is 63, so no, it doesn't make an equation, a true equation. Okay, 5 times z is 5 times 4. I'm going to substitute that in. That would mean 20 equals 25, so no. So you guys do the U try. Okay, so did you get that it's an equation or no? Yes, because 7 plus 15 equals 22, that's true. And anywhere you want is fine. Properties of addition, the commutative property of addition, no matter in what order you add two numbers, the sum is always the same. Order doesn't matter. As long as you're only talking about addition, okay? So A plus B equals B plus A. You could also say A plus B plus C equals C plus B plus A. I mean, addition is commutative. Order does not matter. I think that's fairly intuitive, meaning I think you guys probably kind of knew that, right? Just as you know that A minus C does not equal C minus A, right? The fact that subtraction is not commutative. Okay. You don't need to write that down. Okay, associative property. I think you've seen this before. This still should be reviewed. When you add three numbers, it doesn't matter how you group them. You still get the same answer. So with the commutative property, I think I commute to work. Commuting is moving, so the terms can move around and it doesn't matter. With the associative property, if you want a trick to remember it, here A is associating with B, here B is associating with C, it doesn't matter. How you group them doesn't matter, you still get the same answer. In this one, you're moving the terms. The terms are trading places. In this one, it's the parentheses that are moving. So whatever it takes to help you remember the difference between associative and commutative, but try to come up with a trick to remember if you're having trouble with that. Okay, now we have the identity property of addition. And that's just a number keeps its identity when you add 0 to it. It doesn't change. And that's why it's called the identity property. What do you think is the identity property of multiplication? What could I multiply by a number and the identity stays the same? It doesn't change. Wake up, guys. What can I multiply a number by? 1, and then it stays the same. So that's the identity property of multiplication. So here's the identity property of addition. So now the addition property of opposites, I actually like this title better, the inverse property of addition, but we'll call it this. And what it says is if you add the opposite of a number to the number, you get 0. So the sum of a number and its opposite is 0. All right, so we're going to look at some examples and we're going to decide what property these are. All right, so here we have 4 plus 3 plus 2. The numbers, the terms don't change order. They stay in the same order. What's moving is the parentheses. Who remembers what property that is? Yeah. The parentheses moved, but the terms didn't.
The associative.
Associative. It's the associative properties of addition. I'm going to abbreviate. You guys didn't come here to watch me write. Okay, what about this one? X plus 3 equals 3 plus x. They've traded places. They've moved. There's a hint. They've moved. Yes? Commutative property of addition. Commutative. Whoops. Okay. 7 plus the opposite of 7 equals 0. 7 plus negative 7 equals 0. Who knows what property that is? Go ahead.
Addition.
Addition property of opposites. All right. Negative 12 plus 0 is still negative 12. Who knows what that one is? You guys make sure you learn these because they will be on the test. Any ideas? Yeah.
Identity property.
Good. This is the identity property of addition. And you notice it seems silly that I keep putting of addition, but I want you guys to develop that habit because there are associative, commutative, and identity properties of multiplication too, and we do need to distinguish. Okay, so negative 17 plus 1 equals 1 plus negative 17. What happens? Yes. Commutative property of addition, exactly. All right, now, last one, x plus 9 plus 2, where x and 9 are in parentheses, equals x plus 9 plus 2, where 9 and 2 are in parentheses. You can say x plus 9 inclusive plus 2, that's saying the same thing. What property is that? Go ahead. No? What do you think? The parentheses have moved. The order hasn't changed. Yes. Associative. So you really should practice those. In fact, I sometimes have students make flashcards, and that would be a really good idea for studying for these. Okay? Flashcards work really well for learning properties. You could put your flashcard, your flashcards could have the name on one side and an example on the other side, or a description on the other side. Okay. So now we're just going to do a couple more. We're going to use properties to complete these. So 7 plus 2 plus 1 equals 7 plus 2 plus 1. And that's an example of which property? Anybody? It's the one we just did. Associative, property of addition. Okay, x plus what is the same thing as 15 plus x? This is easier than the other, isn't it? But what property is that? Commutative. Good. Okay, 5x plus what is 0? Negative 5x. And what property is that? The addition property of opposites or the inverse property. So that's great.